Hello, so this is for chemistry. I just want to go over some things and some practice problems that seem to be more difficult than anticipated. So first of all, you need to know that protons and neutrons are inside the nucleus. They are the nucleus. Electrons are outside the nucleus. Protons are positive, neutrons are neutral, and electrons are negative. Okay? Um, And someone brought up valence electrons. All valence electrons are electrons in the outermost shell. So this atom has one valence electron. This also has one valence electron, even though it has lots of other electrons. Valence just means outermost electrons. All right. Remember with the cathode ray experiment, you had the cathode rays going through the tube that had all the air sucked out, so it's a vacuum. And if you bring a positive charge near this ray, it's attracted to it. That is a clue that the ray is made of negative charges. If I bring a negative charge towards it, it's repelled by that negative charge. So that's again further evidence that it is a negatively charged ray or particle, as it actually is. All right. Remember that protons are positive, electrons are negative. So if protons equal electrons, then the atom is neutral. It has no charge. Now, if it loses electrons, it becomes positive. If it gains electrons, it becomes negative. Protons don't change. Um, so these two are true. The number of protons determines what type of element an atom is. We call that the atomic number. Neutral atoms are made of specific numbers of protons and electrons, but the number of neutrons they possess can vary. All right. So protons, if it's a carbon atom, it's always going to have 6 protons. Period. End of story. It's probably will have 6 electrons unless it's become an ion and lost or gained electrons. But the neutrons can actually change because um, it might have 6 neutrons, it might have 7 neutrons, it might have 8 neutrons. And we call those atoms of an element with different numbers of neutrons isotopes. Protons and neutrons are in the nucleus, electrons are outside of the nucleus. Um, now all 4 of these are true statements. The question is, which ones support the idea that the electron is negative? And that's going to be, in this case, A and C. All right, the cathode ray bent towards a positive charge and it bent away from a negative charge. All right, so A is true. Electrons do have mass, it's just very extremely small amount. And C is also true. They have a negative charge. The other 2 are false. Protons are positive, neutrons are neutral, electrons are negative. Which statements are true about protons? Well, protons and neutrons both have a mass 1,800 times greater than the mass of an electron. Protons are positive. Other 2 these are false. An atom can have 2.5 protons. That is false. You either have a proton or you don't. Same thing with neutrons and electrons. They're not fractional. Number of protons and electrons in a neutral atom must be equal. Yes. If you know an atom is neutral, then you know the protons equal the electrons. Which statement about neutrons is true? A and C are true. Protons and neutrons have the same mass. And the major clue for neutrons' existence was the fact that there was mass that they couldn't explain. Neutrons have mass, but they do not have a charge. But they definitely have mass. Neutron is located in the blank of the atom, in the nucleus. Every molecule of carbon dioxide consists of 1 atom of carbon and 2 atoms of oxygen. That is false, because there's not only do you have carbon monoxide, but you also have carbon dioxide. Okay, so there can be more than one. All right. So in this one, you have to use your mass ratios. So the first thing you're going to do is set up the ratio of 15.39 grams of gold for every 2.77 grams of chlorine. All right. So I've lost my cursor. There it is. So that's this right here. Okay. And then we're going to set up one for this. Now we don't know how many grams of gold, and that's what we're looking for. But once we simplify it, we'll know what goes there. So we divide top and bottom by 2.77 because we want that to be 1. So we're going to make that 1, and then that also simplifies this. And so the answer is 5.56 grams. So it's just setting up a ratio and then simplifying it. Okay. Um, Law of definite proportion says that H2O is always H2O. All right, there are 2 compounds of gold and chlorine. In one compound, there is a 15.39 grams of gold for every 2.77 grams of chlorine. So I put that here under known. That's my first ratio. All right, in the other compound, there's 7.74 grams of gold for every 4.18 grams of chlorine. That's my second ratio. Okay, so I have 2 different compounds, compound A, compound B. Find the ratio of masses of gold in the 2 compounds. All right, so again, I'm going to simplify this so that it's gold over 1 gram of chlorine. I'm going to simplify this so that it's 1 gram of gold or 1.85 grams over 1 gram of chlorine. Now, the question is find the ratio of masses of gold in the 2 compounds. So I'm comparing the amount of gold in compound A to the amount of gold in compound B. And so then I take this number and this number, set them as a ratio, and divide and simplify it really, and that gives me 3 over 1, or 3 to 1. So the ratio of gold in compound A to the gold in compound B is 3 to 1. All right. How many grams of carbon would be present in the carbon monoxide that contains 2.66 grams of oxygen? Well, we know we're talking about carbon to oxygen. So the mass of carbon, when we look at the periodic table, which I know we haven't talked about yet, you should have learned about it in 8th grade though, the mass is 12 and the mass of oxygen is 16. Now, I don't know what mass of carbon goes with 2.66 grams of oxygen, but it's going to be a proportion. So I can set these 2 proportions equal to each other and cross multiply. And so then I'm going to end up with 31.92 equals 16x. And that gives me 1.995, which is very easily going to round up to 2. Okay, so that's my answer there. All right, so here, in one compound of lead and sulfur, there are 6.46 grams of lead for every 1 gram of sulfur. So they've already simplified it for us. So there's the problem, or there's the ratio. In another compound of lead and sulfur, there are 3.23 grams of lead for every 1 gram of sulfur. So here we have this. Okay. What is the simple whole number ratio for the masses of lead that can make the compounds with sulfur? So again, we're comparing lead in one compound to lead in the other compound. Okay, so I take this and I take this and I make a ratio, and then I just simplify it. Same way we simplified the other ratios. Divide everything by 3.23 because it's the smallest number, and then that gives me 2 over 1 or 2 to 1. So again, the ratio of lead in compound A to the lead in compound B is 2.1. And I would encourage you to think about it that way because that's the question, is you're looking at lead in the 2 different compounds. All right. In carbon monoxide, there is always 1.33 grams of oxygen for every 1 gram of carbon. How many grams of carbon are there in 16.03 grams of carbon monoxide? Now this one is a little tricky. So the first thing you got to realize is that here they've added all the carbon and oxygen together and given the total mass of 16.03. Well, if they can do that, so can we. So we're going to take the mass of oxygen and the mass of carbon and add them together, and then we know we have 2.33 grams of carbon monoxide. So I'm going to set up a ratio, and I'm going to take the total mass that I know, okay, and set that with 1 gram of carbon, because that's the ratio we're looking at. Carbon, the mass of carbon to the total mass of carbon monoxide. And I'm going to set that equal to X grams of carbon. That's what we're looking for, over 16.03 grams of carbon monoxide. We cross multiply again, and we end up with 16.88 grams of carbon in 16.03 grams of carbon monoxide. So the 6.88 would be your answer. And here you're just setting up a ratio, carbon to hydrogen, which would be 6/12, which reduces down to 1/12. And it says ratio of carbon to hydrogen. So in the boxes you would put 1 and then 12. All right. This one, again, is a little different. The mass ratio of hydrogen, oxygen, and water, or H2O, is 1:8. What is the mass ratio of hydrogen to oxygen in H2O2, or hydrogen peroxide? Well, let's start with the known first. H2O's mass ratio is 1:8 because you take the mass of the element, or the atom, and multiply it by the number of atoms in that formula. So H2, that's really 2 times the mass of 1, or 2 for a total mass. And oxygen, it's H2O, so there's 1 oxygen, so that's 1 times 16. So that gives us a ratio of 2 to 16, or 1:8. Now we do this with H2O2, and the mass ratio is 1 to 16, because we have one, nope, that's hydrogen, yeah, hydrogen's mass is 1, oxygen mass is 16. So we have 2 times 1 is 2, and 2 times 16 is 32. So that gives us 2 to 32 for our ratio, but we simplify that to 1 to 16. Here we're doing something similar. You take the mass, multiply it by the number of atoms. So H6 would be 6 times 1. C2 would be 2 times 12. And so that reduces down to 1 to 4. All right, and then that's it. So I hope this helps. I know it's gone kind of long. So in class, we did a CK12, and then we tried to go over some of these questions. All right. I hope this helps you understand. If you don't, feel free to make comments or ask in class, as long as they're respectful. All right. Have a good day.